but you'll be happier when you're done that you did your best. So now we are going to talk about the last thing we need to be looking at all of these, and that's probability. So everything we did in the last unit, we need to know, and then we're going to be looking at, okay, well, what are the chances now, or what are the odds? Okay, we're going to talk about odds, we're going to talk about what's the probability, the chances, that sort of thing. So I'm just going to go through all of this stuff so we're kind of on the same page. So when we talk about how many cards in a standard deck, 52. We're not even doing any math here. We're just going to point out all the stuff that we should know. How many suits are there? There is 4. Okay, what are they? Clubs, diamonds, hearts, spades. Okay, how many cards are red? There's 26. How many cards are black? 26. Okay, how many cards are there in each suit? There's 13. How many face cards? We have Jack, Queens, and Kings. There's 3 of each suit. Right? So 3 times, there's 4 suits. So there should be 12 total. Okay? Hopefully you're at that stage that you are absolutely sick of card questions. Like just even seeing it, it's like, ugh. Okay? And, you know, obviously I don't want you to be bored in here, but I do want, like, because the opposite of anxiety is like, again, this question. And I hope you feel that way when you're going through, when you went through the exam yesterday. Like, did it seem routine? Did it seem like this question again? There was no surprises, right? That's how you know you're ready, right? Because if you're like, oh crap, this one, I never did get this one, okay? Well, that was your fault, right? How could you fix that? You've got to come, you got to ask, you got to rewrite those quizzes. You got to be like, give me how do I know how to do this one all the time? That's the stuff you have to advocate for yourself. Okay, now when we just talk about numbers, right? How many digits are there? There's 10, 0 through 9. Okay, and I had a few people yesterday, because they will not say, it says you get to use, you know, all the digits, right? People were asking, is it 0 through 9? Of course I'd say yes, right? Like I'm going to help them out, but that has to be, I don't want you in the diploma going like, is that 1 to 9? Is that 0 to 9? It's got to be, I know that's 0 to 9. Okay, how many digits are odd? We would have 5, and I'm going to list them. 1, 3, 5, 7, 9. How many digits are even? That would be 5. That would be 0, 2, don't forget about 0, 4, 6, and 8. And there is no 10 because that's a double-digit number. What digits at the end of a number make it even? Okay, because they may ask this. So at the end of, I don't care if it's 20 digits long. You just look at the last one, right? So you got to make sure it ends in 0, 2, 4, 6, 8. And people get messed up on that sometimes. Like they'll look at 2005 and they'll say that's even. I'll go, what are you talking about? And they're like, and then they're just like, oh, I can't believe it. Why did I think that way, right? And that's when we check over our tests and we see that and we're like, holy crap, what was I thinking, right? And that's like a good catch. That's one of those where you're like, okay, I'm glad I caught that one, right? And sometimes when you're out in, you know, outside the gym or whatever, when you get out and you see and you're like, oh, I'm so glad I caught number 4 on this one. And there'll be someone going, oh, crap, I did not see that. I forgot about that or whatever, right? Now, what digits at the end make it odd? Again, if it ends in 1, 3, 5, 7, or 9. Okay? How many letters are there in the English alphabet? There is your 26. How many vowels? 5. List them. A, E, I, O, and U. Okay? Yeah, we're not going to talk about sometimes why. And how many consonants are there? 21, and that's all the rest. Okay? So you don't want to be hung up on these terms when you're doing the diploma. Okay? So these are all the kind of stuff they'll throw in these probability questions. Dice. Dice are always in there. Dice, coins, you name it, right? Now dice, how many numbers are on a die? There are 6. 1, 2, 3, 4, 5, and 6. What is the largest sum you can get on 2 dice? It's 12. What's the smallest sum? 2. Now, and we're going to do this once because I want you to be able to, so here's your die, your top one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So probability questions sometimes are, what are the chances that you would get a sum of 7 or more? That's it. What are the chances you roll 2 die, would you get 7 or more? And you've got to go to something like this. So we're going to add, see, it's like if I roll a 1 and a 1, I will get 2. If I roll a 1 and a 2, I'll get 3. That's 4, 5, 6, 7. So that's when you roll a 6 and a 1, you'll get 7, right? Does everyone see how I'm getting these numbers? This is the only way to do this question. When they ask you, what are the chances of getting a sum greater than 7? I wouldn't just try and think of it in my head. I would do this chart. Okay, and then 2 plus 1, that's 3, 4, 5, 6, 7, 8. Check your last one. 6, 2 is 8, yeah. Then 3 and 1 is 4, 5, 6, 7, 8, 9. 4 and 1 is 5, 6, 7, 8, 9, 10. 5 is 5 and 1 is 6, 7, 8, 9, 10, 11. And then if you go 6 plus 1, that's 7, 8, 9, 10, 11, 12. So they may ask, like, what are the chances of getting a sum greater than 7? Okay, greater than 7. Well, that's not 7. Okay, that would be, I'm just going to highlight here, that would be these, right? So then I would count. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I would have a 16 out of, how many are there? 6 times 6? 36, and that would go down to 8 out of 18. It should be 4 out of 9, right? So that's all the diploma may ask. Like, if you roll 2 dice, what would be the chances of getting a sum over 7? Okay, and you just have to do them all, count them, 4 to 9 chance, right? Like that's how you do that question. I can't get any shorter or any fancier or whatever than that, but you're going to have to learn how to do this kind of stuff. Yeah, they might have it, but they'll probably, it's mostly going to be 4 out of 9. Now, we're going to go, we're going to talk about this question here. When 3 coins are tossed, what's the probability that result exactly 2 heads? Okay, well, we're going to go all the way to the tree diagram. Now, the first coin, so you got to know how to do these, right? Because these are going to get you far. I know they may seem trivial, but they're not. This is the way you do them. I mean, just like that chart we just did may seem trivial, but it's the best way I can show you that you're going to get the right answer. Now, second coin, so we go like this, right? We go heads, tails, heads, tails. Okay, then third coin, we split this up into heads, tails. This into heads, tails. This into heads, tails. And this into heads, tails. Now this is the best way I know how to stay organized because, man, these can get kind of weird when you're trying to just think of them. Okay, so there could be heads, heads, heads. There could be heads, tails, heads. Now should I go heads, heads, tails? Like, how do you get them all without knowing you're missing them? So I find this way is quite nice. And all you do is you go like this. Heads, heads, heads. That's the outcome. Do you see how you multiply? You go this, this, that. That's heads, heads, heads. Then you've got heads, heads, tails. Now we're going to go down heads, tails, heads. then heads, tails, tails. Okay. Now I'm going to go with the other side. So now what if I get tails, heads, heads? Okay, and then I got tails, heads, tails. Then I got tails, tails, heads. And tails, tails, tails. Okay? If you got a better way, I'm all open, right? Like you know, with 8 it's not so bad. Sometimes I can, you know, okay, I'm going to do heads, all those ones, and then I'm going to, right? But you do lose track. Now, if we go back to our first question, it said right here of the probability of getting exactly 2 heads. So that would be this, this, this. I do not see any more. So the theoretical probability would be 3 out of 8. Again, is this horribly difficult stuff? No, but if you don't know how to lay out a strategy, it can get pretty daunting. Some students just give up. Like, you know, maybe 8's not so bad. Yeah. You shouldn't have 9. Hopefully I don't have 9. 1, 2, 3, 4, 5, 6, 7, 8. Because fundamental accounting principle, 2 times 2 times 2 should be 8. So we, in the last one, we figured out how many possibilities, how many outcomes. We got that. Like that's 2 times 2 times 2. But now, what if we want to be specific about what are we going to call a success? Well, this one said, I want success to be exactly 2 heads. Okay, there's 1, 2, 3. So you have a 3 out of 8 chance of being successful if you were to do that. And this is called the theoretical probability, not the experimental. Experimental is actually flipping coins, right? And if you just did it 8 times or whatever, you might find it's really weird, right? Like, theoretically, if you flip a coin, shouldn't half the time it come up heads and half the time it come in tails, right? You'd think if you did it 10 times, it should be 5 heads, 5 tails, right? It doesn't happen though. Not 10 times. If you did it 10 times, sometimes you can get all 10 times as heads. Okay? That'll happen when you do lower numbers. But if you had to do it 1,000,000 times, you'll find it'll be like 500,000, 500,000. So the bigger the number is in experimental, the closer it gets to probable. Okay? But low numbers can be quite deceiving sometimes. I mean, hey, you flip a coin twice. Should come up heads one time, tails the other. I think we could all say it's probably a good chance it just might go heads, heads. Right? No one would be freaked out by that. Right? But why did it come up heads, tails? Because you only did it twice. Okay? You didn't do enough. So here's what we have to talk about. There's knowing the probability of making decisions. There's experimental probability. So n, the number of A. A is, we call this number of times it occurs. A occurs. So A can be anything you pick, right? And this is the number of trials. So if I flipped it 50 times, number of trials, sorry. If I did it 50 times, that's where the 50 goes. And how many times I wanted heads? That goes up top. Now, theoretical probability is number of favorable outcomes over number of total outcomes. And we basically spent the whole last 2 units coming up with the number of total outcomes. You guys know how to do that now. I should have been able to ask you if I was flipping a coin 3 times, how many possibilities? And you should have said, well, that's 2 times 2 times 2. Okay, that's 8. Because we've done that before. Now, when we talk important things to remember. Now, let's talk about if we are throwing a standard die. Okay, It's called a die when it's 1, dice when it's 2. The event, throw an odd number. Okay, so if you're throwing a die, the event is throw an odd number. What's the probability that you would throw an odd number? Well, 1, 3, or 5, that's 3 out of, what are all the possibilities? 6, right? So it would be, so we'd say this, the probability of tossing heads would be 3 out of 6, which equals 1/2, which equals 0.5, which equals 50%. So these three are the way it can be presented. And you have to be able to adjust yourselves on those at all times. Okay? You have to always know 0.5 means 50%. 1/2 is 0.5, right? Those all have to be interchangeable, and it could be asked anyway in a test. Now, they're usually not jerks on a test and say, what's the percent? And they have the decimal as A and the percent as C. They don't usually do that, right? That's actually just quite mean, right? And that doesn't test their mathematical knowledge. That's like tricking them, right? So I'm very careful even on my test not to trick students, right? It might be what is 0.5 written as a percent, and I might say 0.5% in that's fair, right? I asked you, take this to percent, and if you think 0.5 is the same thing as 0.5%, then you didn't learn that outcome very well, right? But having both of those options in the multiple choice, that's mean, okay? Because that'll catch your best student. Okay, so visualize tossing a 6-sided die. What's the probability of getting a 5? So this is how we write it, P of 5. Okay, or you could put the number 5 in there. So we want the number of 5s over the number of sides. So the number of 5s would be 1, right, over 6. Okay, what is the theoretical probability of getting an even number? If it said experimental probability, you'd be like, what, so am I supposed to do it right now? Because that's the only way you could do experimental probabilities, to do the experiment. So they'll ask for theoretical of getting an even number. Now, first of all, list all of your successes. Those would be considered a success. And we all know this, right? Like if someone said that, you would in your mind know what's going to help you win now, right? So the way we say this, the probability of even is the number of even over number of sides. So there would be 3 out of 6, which would be 1/2, right? Which could be 0.5 or 50% chance. Okay, what's the theoretical probability of getting a number greater than 2? Now always be proactive and write them down. Don't just go in your head, yeah, okay, good, and then do the question, right? That's where we all make mistakes. That's where I make a lot of mistakes, right? So after like getting beat down enough, I'm like, okay, I will do it now. Like every time you get that test back, you're like, seriously, why did I do that? And I can see I've got nothing written on the question, right? So you're like, well, I guess I deserve it, right? I didn't do that 5 seconds of work it took me. So greater than 2, let me think about it. That would be 3, 4, 5, or 6. Write them out. Okay, so how would you write that? That's probability of greater than 2. So what's the number greater than 2 over the number of sides, right? That's 4 over 6, which is 2/3. So these 3 units that we've been doing in kind of unison together, they're the ones that you really got to be on your game when you're writing your diploma, right? So like I'm sure hoping is that the night before is the least amount of studying you'll need to do on this. Like it's just like, okay, got a diploma tomorrow. I know my stuff. I just need to be well rested so I can just think these questions through all the time. Okay, so now this is a big thing that will show up. They'll have one of these questions on the diploma. Is it fair or is it not fair? So you have to learn how to figure out if things are fair or not. Okay? And sometimes they seem Like tossing a coin between two people, that's fair, right? No one has an advantage over the other one. That one's easy. They're not going to be that nice, though. Let's do some of these, and we'll see here. Now, Matt and Pat each toss a coin. If the coins land on as both heads or both tails, Matt turned to Mart. Mart wins. Mart's like, fine, you want to call me Mart as long as I win. If the coin land, I never saw that before. If the coins land as a head and a tail, Pat A gets to keep his name and he wins. Okay? So what are all my outcomes? Like, I want to know what could happen. What are all the outcomes? Yes? Okay? Now again, you could have done this, heads, tails, right? It does take a long time, right? But you're going to have one of these in the deployment. And one time, like a lot of time, we're talking a minute. That's not a long time, right? So this, I don't know. I just have had too much experience with students missing these, right? It's hard, like two isn't bad, eh? But when you have like, you know, two dice are thrown, right? You got to list them all, or, you know, if you're like, you can just visualize it, like, good for you. I can't, so that's what I have to do. So these are my outcomes. Now, if for Mart to win, both heads or both tails. So Mart wins there. So Mart has a, okay, right? And if you look at, these ones are Pat. So Pat has a 1. You know what? I don't want to skip this. I'll just put, so a 2 out of 4, which is 1/2. And he's got a, Pat's got a 2 out of 4, or 1/2. Okay? So it's fair. Now, unfortunately, it will not be that easy on the diploma, but it's for you to be able to understand the concept at this point. Now, let's get into B. Trina, Lena, and Gina each toss a coin. If all 3 coins land as heads, Trina wins. If all 3, look at another typo, all 3 coins land as rails, Lena wins. And otherwise, Gina wins. Okay? So, how do you get them all? Now, we've already done this one, right? If you go back to the last page, so look back. But these were the outcomes. Heads, heads, heads. Heads, heads, tails. Heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Out of room. Got 5 so far. Where was I? Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And tails, tails, tails. Okay, so what are the chances Trina would win? So Trina's 1 out of 8. Because Trina's heads. If all 3 coins land as tails, okay, so Lena, 1 out of 8. And Gina would win 6 out of 8. She gets all the rest. So she has a 3 out of 4. So Gina is favored to win. Yep. Gina was just that kind of girl. Okay, so this is the one that I was talking about before. It says Anne and Dan each rolled a standard die. If the sum of the 2 is greater than 7, and again, read well. Doesn't say when it equals 7. So if it's greater than 7, does that include 7? No, it doesn't include 7. So that would be 8 to 12, correct? Now, Anne would win. If the sum is less than 7, Dan wins. If the sum is 7, they tie. Now, instead of writing our chart over again, we can go back over here. Okay, I must have counted wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I did. Okay, so go back. It's 15 out of 36, right? So Anne wins if it's greater than 7. So that's 15 out of 36. And Dan would win if it is less than. Okay, I'm going to change colors here. Okay, so this is if Dan wins. And you can see that is also 15 out of 36, right? And it's if they get 7, it's a tie. So you can see by looking at that, okay, so Anne turned out to be 15 over 36. Dan was 15 out of 36. Therefore, the game is fair. Okay, so what was I trying to show you today? Basically, we just need to get good at all the dice. We got to with cards. We got to be familiar with your vowels, your consonants, right? I don't want that to be the weird thing when you're dealing with these. That shouldn't be the barrier, right? It should be, you know what you're doing with these. And again, my hope for you is that when you're doing the diploma, you're like, oh, this question again. Oh, I've seen this one so many times, like, right? And I have been, and it's a good feeling. It doesn't sound like it's good, but it's really good to be bored on a diploma when it's just this question again and this one. It is a really good feeling because you keep relaxed, number one, but number two, you obviously do get a good mark, right? So we're working on page 52, 53, and 55. Okay, it's fast stuff.